Okay, everyone is settled. Shall we start? So, till last time we have been looking at derivatives of polynomial functions or algebraic functions like square root of x, these kind of things. Oh, by the way, I should have given you, I didn't give you any. So today we'll start trigonometric, but I'll give you some homework first. I forgot to give you some homework. So what's the derivative of square root of x? Okay, let's do it here in a moment. What's that? So it is d over dx of x to the minus half. Sorry, x to the half. Correct? That is what is square root of x is. So it is 1 over 2 x to the minus half, right? Half minus 1, which is minus half. So this is 1 over 2 root x. Okay, this you should remember. There are certain results that you should have in your memory, and not everything you should have in your memory. It's wastage, right? So, but this result is something you should have in your memory. Find out what d over dx of x to the 3 halves is. And similar things, okay? So take it as a homework. It will give you some exercise. Okay, so let's move on to trigonometric functions. So what I'll do is, I'll see sine and cos, and then tan, cot, cosec, sec, and these things. But they are all made up of sine and cos. Okay, in fact, sine and cos are also related, but let's take them, I mean, they are independent. So I should also, maybe once you grow up a little bit more, I'll tell you what I meant by saying they are independent, okay? Not now. So let's take the derivatives of sine function and cosine function. With the help of that and the 3 rules that I wrote, I can tell you the derivatives of product of sine, cosines and whatever. Okay, so that's the reason I want to play a little bit with these derivatives of sines and cosines. So I want to know this, I want to know that, and with that I will be able to. Okay, so let's find this one first. So d over dx of sine of x is, take that function which is sine, evaluate at x plus h, then subtract from this and take the limit h going to 0. Okay. So instead of f, you have sine. You have specified the function. Okay. Now that's easy. It's easy because you know what sine of a plus b is. Sine of a plus b is, you remember? I've forgotten, huh? Sin a cos b plus cos a sin b. Okay, so we will use this. Sin of a plus b is equal to sin a cos b plus cos a sin b. Okay, where a is the first angle, b is the second. It doesn't matter, it is symmetric, but when I am writing it's like this. So what is this? Sin x cos h plus cos x sin h minus sin x over h. Is it fine? Okay, so I will write this as, so what will be better is, instead of writing limit h goes to 0 every time and wasting time like I am, what you should do is just work with the numerator. Okay, and do all the massage, and then only at the end, I mean, work with this thing, only at the end put h going to 0 limit. Okay, so don't write that equality and it will be fine. So this says, let's take sin x common between this and that. So I have sine of x times cos of h minus 1, and this 1 over h comes here. Okay, remember, limit of sum of two functions is sum of the individual limits. So have taken these two for now. Now this one is left. So plus limit h going to 0 cos of x sine of h. I could avoid one. As far as cos of x is concerned, there is no h. Since there is no h in it, it's a constant for the limit process. So that comes out of the limit. Is that okay? So you get cos of h. Okay, I will not write it like this. I will write cos of h. What happened?
Cos x. Cos of x. There is no h.
This one, right? Sorry, yeah. Cos of x, limit h going to 0, h tending to 0, tending is the right word, h tends to 0, sine h over h. Is that okay? What happened? It becomes shorter, right? No? It's okay. That's all magic. Magic happens here. Okay, it's captured in the camera, I hope. Entire thing. Good. So, do you remember what sine h over h is? H goes to 0. As h goes to 0? 0. Okay. What is limit h going to 0 sine of h? Sine of h. Just sine of h, not the denominator. What is the limit of sine of h as h goes to 0? 0. Correct. Then what's the ratio? Limit of the ratio? How do you know? 0 over 0 can be anything, right? It's not just because it's 0 over 0, it's 1. It can be anything. So you need to know how sine of h behaves near h equal to 0. So you can either look into book for this limit, or maybe I'll make a video and put it. But the value is 1. Okay, you can see the proofs in the books or in my video. But I'll give you a way of remembering this, why it is 1. Okay, I'll give you a way. It's not a proof. Okay, because drawing diagrams will not give you a proof, but you can have this in memory. And lines are very bad. Okay, I will need straight lines, so I'll go, where was it? Here? You see, I keep forgetting. Here. Okay. So I'm trying to give you a way of remembering this. I'm not giving you any proof. Okay, you remember sine function looks like this. Something like this. Is this not visible? Okay, sorry. This should have been. Okay, it's fine. Any problem? It's okay. Sure. I was obstructing it, huh? So this should go below, and it's not looking very nice. But the point is this. Imagine just looking at this part. You look only at this part. Do you see a straight line at 45 degrees? In the neighborhood of origin, it's a straight line at 45 degrees. Okay? So the function sine of x for very small values of x, for when you are very close to x equal to 0, Okay, in that range, it is almost like x. If it is almost like x, then sine of h is almost like h. H divided by h is 1. So the limit will be 1. But this, I mean, see, it could have, real sine function could have some angle, but it does not have. So I'm not giving you proof. This is not a proof. This is just a way to remember, okay? So sine h over h is 1. Where did my pen go? So that limit is 1. Okay, and you have cos of x here. Now we want to know the limit of this. So this sine of x, since it does not depend on h equal to 0, it will come out, and you need to know the limit of cos h minus 1 over h. Okay, again, so this is so here, that's the homework you should do, or you should refer to a book if you have not seen this already, or to my video on limits. Cos of h minus 1 over h as h goes to 0 is equal to 0. And second exercise is limit h goes to 0, sine of h over h is equal to 1. Okay, do both of these, and then that is what we use here. So it is sine of x does not depend on h, so it's a constant, it comes out. When I say it's constant for that limit, because it's for variable x, times limit of this as h goes to 0, but that is 0. So this is times 0 plus cos of x times 1. So what do you get? Cos of x. So d over dx of sine of x is cos of x. That's our result. Are you happy? Now you can differentiate sine of x. Oh, looks like you're very excited. Is that fine? Looks like I was very excited, so I just did the derivation for all of these functions. But I think I can leave it as an exercise to you. Okay? Are you comfortable? Okay, if you are, then take this homework. Show that d over dx of cos of x is equal to sine of x. Okay, so when you take the derivative of sine, you get cos. When you take the derivative of cos, you get sine, but with a minus sign. Very good. Minus sign, okay? So don't forget the minus sign. The boxes look ugly. No? It's fine. Excellent. We are making good progress. So what I'll do is, I'll give you two simple exercises. Can you remember these results? These results you should remember. Derivative of sine is cos, cos is minus sine. Exercise. Okay, I'll keep it here so that you can, sorry, maybe I'll do it here. So exercises. Let's find the derivative of sine of x plus cos of x. Okay, and we should use d over dx of sine of x is cos of x, and d over dx of cos of x is minus sine of x. Okay, so what is this? Derivative of sine is, see, remember rule number 1. Rule number 1 is, I can just take the derivative of this and add the derivative of that. So sine of x will have derivative cos of x. Cos of x will have minus sine of x. That's the result. Okay, another one. D over dx of This is nice. Sine of x times cos of x. Can you do this? Use the Leibniz rule or the product rule. Rule number, I think, 2. Yeah. Find it out and let me know your answer. Okay, keep your answer with you and then we'll compare. Okay. You're copying with each other. Okay. No, you should not be looking in someone else's notebook. You're done. Okay, here. Yeah, pay attention here. It's okay. Let's look at it. So what the rule says, take the first function and take the derivative of second function. What's the derivative of second function? Minus sine of x. What's the derivative of cos? That is minus sine. Plus, keep the first function. Sorry, that's not how I mean, it's correct, but what I wrote is correct, but that's not the order in which I want to do. I'll take the derivative of first one, which is cos of x. Then this remains as it is, plus first function remains as it is. Take the derivative of second one, it is minus sine of x. So what do you get? You get cos of x whole squared minus sine of x whole squared. Okay. Sometimes, and in fact most of the times in books, it is written as cos square x. Okay, and it is written as sine square x. So, okay, good that you knew this. So, cos x whole squared is also written as cos square x. Okay, when you write it this way, it does not mean cos of x. That's not what is usually meant. It is meant this. So you can write it that way also. Okay, that's the same thing, same notation. Now, what is cos of 2 theta? It is cos square theta minus sine square theta. So that is cos of 2x. Is that okay? Did you also get this? Okay, now I'll show you something nice. Or rather, let's say something curious. And later we will see the explanation behind that curiosity. Okay? So I'll just show you something. If I succeed in that. Yeah. Here. Sine of x, cos of x. What is sine of 2 theta? What is sine of 2x? It is 2 sine x cos x. You don't remember. See, sine of a plus b is sine a cos b plus cos a sine b. If a and b are equal, sine of 2a. If b is equal to a, then it becomes sine of 2a is sine a cos a plus cos a sine a. So it is 2 times sine a cos a. Sine of 2a is 2 sine a cos a. Is that okay? Now here look at this. This thing is what? D over dx. Let me multiply a factor of 2. Okay, if I multiply a factor of 2, then it will be 2 sine x cos x. Okay, it is not equal. I am not saying it's equal. I am saying I am just multiplying the thing by 2. Then it becomes sine of 2x. Okay, I have just multiplied a 2 factor here. Then the result will also be a factor of 2 here. Okay, if you like it that way, then I will just divide by 2. It's okay. Okay, now they are equal. So d over dx, this is half sine of 2x. Half is here, sine of 2x. Then it is equal to, what did we get? Cos of 2x. Correct? Or d over dx sine of 2x is, multiply 2 in this equation, you get 2 cos of 2x. So taking a derivative of sine x gave you cos x, but taking a derivative of sine 2x almost gave you cos 2x with an additional factor. That 2 is coming because of that. Okay, we'll see that later. Okay, later I'll give you a result which will give you a more general perspective why you get such results. Okay, maybe after a few lectures. Okay, those of you who are aware of this will immediately identify what is happening. Okay, so I'll give you some homework. I think if you are comfortable with trigonometry and taking limits, we have taken lots of limits already, you will be able to do the following. You'll be able to take the derivatives of sine and functions made out of sine and cos. So tan is sine over cos, and you already know how to take the derivative of f over g. So you will be able to find it out. Okay, so I'll give you the results. Okay, I'll just write down from my memory, and it's useful to have them in your memory. Okay, so first one is d over dx sine of x is equal to cos of x, that we have already proved. This I think I gave as a homework, or maybe I did this, I don't remember. It was a homework, right? Okay, show that. Now this is a homework again. Tan of x secant square x. Remember, when I write secant square x, it means secant x whole squared. That's the usual notation. And show that d over dx of cot x, cot is 1 over tan, which is cos over sine, is equal to minus cosecant square x. Okay, where what is secant of x? Secant of x is 1 over cos x. Okay, that's the definition. When I put 3 lines, it means definition, or sometimes it means identity. Okay, and what is cosecant of x? Correct? Okay, we are almost there. Shall I give you one homework, or shall I just 2 more minutes and we are done? We are done. I have more. Okay, maybe another time, but let's finish this one at least. Okay. Shall I proceed or no? It's okay now? Okay, so I'll give you a homework. Show that d over dx of cos of 2x is equal to minus 2 times sine of 2x. Okay, that you should show. Okay, don't use any fancy rules. Don't use rules which I haven't told you yet. Okay, we need good practice. Okay, then I'll do one exercise for you, and then we will stop. Yeah, I'll just do one exercise. No, I'll do 2 exercises, because the second one is easy. Okay, so let's take sine of x You know what smart people do? They make their own exercises. They don't wait for others to give something. You can come up with such things, right? You can come up with similar things. So let's find the result for this. Using the rules now. We are not going to do it ab initio. We are not going to take limits. So this is equal to, remember what is f over g prime, f over g, derivative of f over g, it is f prime g minus f g prime over g square. Remember this? Okay? Always start with the derivative on the first function. That's why I am being very careful with the order. So, so f is sine of x now and g is 1 plus cos x. So the derivative of sine x, f is, so f is sine x and g is 1 plus cos x in this problem. So let's take derivative of sine x is cos of x times g. What is g? 1 plus cos x minus, what is f? Again sine x. What is g prime? G prime is the derivative of this. Derivative of 1 is 0 and the derivative of cos is minus sine. So you get a minus sine of x. Are you following? Is that okay? Divided by 1 plus cos x whole squared. 1 plus cos x whole square, which is, so cos x into 1 is cos x into cos x is cos square x, and here you have plus sine square x, minus times minus cancel, so that gives you cos, so you get cos x plus cos square x plus sine square x, but cos square x plus sine square x is identically 1, right? Cos square x plus sine square x is identically 1. Okay? Any problem? Is this okay? This you have forgotten, that's coming from Pythagoras theorem. So what's left on the numerator? In the numerator you are just left with cos of x coming from here. Something wrong? Did I make a mistake? I think I made a mistake. No, sorry, I made a mistake. That is 1, not 0, right? So that is 1.
1 plus cos x.
Divided by 1 plus cos of x squared. Cancelling this gives you okay. So similarly you can do these kind of things, some other problems of this kind, and not only these, you can also see right now the problems, all the problems that we did involved either trigonometric functions or polynomial functions, but who stops you from multiplying them? So I'll just give you one. Suppose f of x is x times sine of x, then what's the derivative? F prime of x is derivative of first function, which is 1, times second function plus first function times the derivative of second function. So you have sine x plus x cos x. Is that okay? Okay, I think. Any problem? It's okay, right? There's no mistake. Okay, good. So I would recommend that you keep do the derivation and keep certain things in your mind. Okay, some results should be in your mind. So what happened? It went that far. What happened?
25.
25 and then no.
25.
Go to 25.
Scroll up.
Oh, it's not a page now.
Yeah.
So when I make a PDF file, there will be a trouble.
Yes.
Horrible. Now we are going to have trouble because of that. It's okay. Oh. So
this is one page.
no, but how will it print on one page? Then it will become very small. Okay, we'll see. Right now we have other miseries. So Oh. Okay. Yeah. These two you should definitely remember, and also the derivatives of tan and cot. These four you should definitely remember. Okay, then yeah, I think as far as trigonometric ones are concerned, this is what you should remember. Okay, so as I said in the beginning, after this now we will return back to our expedition. Okay, mountains and valleys, with which we had started, and then we'll continue from there. Okay, so let's stop here.